Assalamu alaikum. This is Dr. Rahman Ali, and we are here to discuss the arithmetic operators in SQL. Before that, we have discussed the select query, and we will be proceeding with this one now. Arithmetic operators, they are division, multiply, plus, and minus. We will be understanding them here in this tutorial and practically demonstrating its impact within the select query. For example, this is our table that we have already demonstrated in our last video of the select statement or select script with its different clauses. You can watch from there. I have this table, and what I am going to do that I am using the select statement with arithmetic operator, and what I am interested is that I am calculating, I am using the computed column. So here I have name and salary column, but when I want to calculate the 10% increase on this salary, so the 10% increase on this salary column is not here, so I am creating a new column which is called computed column from this existing column, and for that I am using an arithmetic operator. What I will be doing, I will be multiplying salary with 0.1, and it will give me 10% increase. And as we already discussed that this new column, I am naming it with 10% increase bonus, so I am using the as 10% bonus, and I am doing this from this implied table, and for those salary where salary range is less than 5,000. The scenario is that those employees whose salaries are less than 5,000, they need to be helped out and supported. So the organization is trying to give them 10% increase in their salary. That's why I need this kind of analysis and computation. So for this I will to demonstrate it, I'm going to open my MySQL, and here I have already created this table and inserted the same data which are shown here, and then I applied different select queries from the last lecture, so you should follow that from the last tutorial. Here I am going to demonstrate this arithmetic operator. So I'm going to copy this query and put it here, and this is employee underscore name. So I'm asking that retrieve me employee name, salary, and salary multiplied by 10% as 10% bonus from the employee table, and for those employee where salary is less than 5,000, because I need to support them with the additional 10% increase. So this is the new column that is created, this is the 10% bonus, and for this salary only two salaries were found less than or equal to less than 5,000, 4,000 and 4,050, and 10% was calculated is a new column. So here this star is the arithmetic operator, and it has calculated the 10% as a new column, and this new column is called computed column. Now let's see another example, that now when we are going to apply the 10% increase on the salary for those whose salary is less than 5,000, then what will be the new salary? So for the new salary, the 10% increase, this is the actual salary, and I will add the 10% increase. This is salary into 0.01% as a 10% increase. I will add this with the original salary, and it will become as the final salary. So again the computing column with the arithmetic operator plus is used here, plus and multiply is used here. So let me execute this statement. Give me the employee name and their salary, and add the original salary with the 10%. this is the 10% increase in the salary, this is the bonus, and then the original salary and 10% increase, add them as the final column. When I will execute it, it will calculate me. Yes, this is the 10% increase that we already did it here in our previous query, in this query, and now we add this 10% increase to the original salary, and this is the final salary for this. So this is again a computed column, and here the plus, the addition and multiplication operators, arithmetic operators are used. And this arithmetic operator can also be used on the on the date column as well, but here it is not the arithmetic operator, it is the comparison operator. So comparison operator could also be used, greater than or less than. So here in this case, I don't have the column date of birth in my database, and here I am applying the comparison operator on the date of birth. So first I need to create this date of birth column and then add these values, then I can apply this query. So let me do it first, then I will apply this query. I am adding a new column, date of birth, and adding these values using a script to the already created employee table, and then I will execute it. So let's do that. So let's alter this table. I am going to alter this table, employee, and adding the new column as date of birth whose type is date. So when I will execute it, it will create the empty column here, and now I am going to add each of this date of birth to each of this employee. So for that I use the update statement, update set, update table employee, and set the date of birth column to this value where the employee ID is 1, then 2, 3, 4, 5, and all the dates. So it will update all the columns with these, the empty column with these values. Now the date is entered here, and if I want to see it, select asterisk from employee, so I can see that this new column would have been added, and yeah, this has been added, and the date of birth has been values has been added. So now I'm using this query that select me all those employee from this table where the date of birth is greater than this particular date of birth. So here this is the relational or comparison operator that we are using, and they can be used the same way as the normal arithmetic operators. When I will execute it, so let me check it what happened at sorry, I executed the wrong statement. The select, I also select static at this one, so that's why the result is incorrect. Now you can see what is again what is the problem. Unknown name. Oh, this is not a name in my table, it is emp underscore name. This is not here. When I created the table, it is emp underscore name. When I will execute it, so yeah, only these two dates are satisfying which are greater than 1990, and that is retrieved. So this query shows us that the relational operator could also be used, and they could be applied on date column as well. And here we can also do that arithmetics on that. Why I use the relational operator for the date? Because I am using the arithmetic operator. What I want to do next is that this is the date of birth or the employee, and I want to find out their retirement date. So retirement date is normally 60 years. So what I will do, I will extract the year from this date of birth column and will add 60 to that, and that will give me the retirement year. So for that, what I do, that I am extracting the year. Year is a function here which takes the date of birth, this whole value, and will extract only the year out of them, and will add 60 to that one, and giving an alias of retirement underscore year will give me the retirement year for those employees whose salary is less than that. But it's not necessary that you extract you filter with the salary. Without this you can also do it. So when I will execute it, this query, what it will do, again this I'm always making a mistake. This is column name is employee underscore name. When I will execute it, it will show me, yeah, the retirement is for these two employees is 45 and 55. If I exclude this where class from this query, so it will give me the retirement years for all the 5 employees. So this is how arithmetic operator could also be, plus arithmetic operator could also be used with the data type as well. Here now, when we have completed the arithmetic operator, plus, minus, multiply, and division, you can also use the division and minus, and there is the power as well. We didn't demonstrate it here, but you can do that by considering a different scenario. The same method, same procedure is used. Now what is precedence? Precedence means that we have these arithmetic operator. The most important, first we will be solving the parentheses, then the power, and after that multiplication and division has the same level, but will be solved in the order of appearance. Who come first will be solved first, and similarly the next level is for the plus and minus in their order of appearance. Here we are going to demonstrate this with an example, and the example is that, for example, we want to give a flat $500 increase to the salary for each employee, and 10% flat 500 USD is medical allowance to each employee, and on top of that we are giving 10% increase in the salary. So how we could do that? For doing this, we are going to demonstrate the rule of precedence. So one way is that add this 500 medical allowance to the salary, and then after that compute the 10% increase. So this is the arithmetic expression without parentheses. So here, and another way is that add the 500 flat increase to the salary, and then compute the 10% on the increased salary. So if I don't use the parentheses, then it may be the order of precedence will not work properly, because first it will, in this case, it will first calculate the 10% increase on 500, and it will be 50, and will add 50 to the salary of each person, and it will be 5,050, 4,000. So this is without parentheses. But the actual case is not like this. First it should be added with the salary, and then the 10% of the increase should be calculated. So when I will execute this query, you will see the difference. Okay, now let's see that this is just comment, nothing else, and I'm executing this one. But first let me emp underscore name, and now also copy this one and execute it now, and you will see that there will be quite difference in the salary. Without the parenthesis mean, as I told you, that 50 and 50 will be the increase on the 500, and here the actual case is not like this. Without parenthesis this will be the increase, and with parenthesis this will be the increase. So this is quite different from the quite different when you don't apply the rule of precedence. So it is very important in arithmetic operator. I hope you would have understood it properly. And next we will be demonstrating the logical operator and RA not. So you should wait for it. Thank you.